Now, let us do a quick revision first and then we'll proceed ahead. So what did we see yesterday? We saw logistic regression, right? We started with logistic regression yesterday. We covered all the theory. So what did we see? Yes, guys, help me revise. So we first saw why do we need logistic regression when our dependent variable is categorical. We need logistic regression. Okay. So dependent variable is categorical. We use logistic regression. Now I can ask a question here. Okay. So one question I just remembered out of the blue. Why can't you use linear regression when your dependent variable is categorical? Why can't I use this? Why can't I use this when my dependent variable is categorical? So y will be 0 and 1 in that case. Why can't I use this? Yes, guys, try to answer this. Why can't I use a linear regression when my dependent variable is 0 and 1? Why can't I use that? Okay. Okay, I think I have discussed this. So the range of linear regression, if you see, yeah, okay, yes, so you are right. So the range of linear regression is minus infinity to plus infinity, right? This y can go from minus infinity to plus infinity depending on what x you give. If you give x very large, it will go towards plus infinity. If you give x very small, it will go towards minus infinity. So y basically can take range, can take values from minus infinity to plus infinity. Okay, but when your y is a when your dependent variable is zeros and ones, okay, or two or three categories, it has to take only these numbers. It cannot be 5 or minus 5. That will not make sense. Okay, it will not make sense. So that is why we cannot use linear regression in case of logistic regression, because it can give you any outputs which will not make sense. So then we saw, so what do? Basically we take the same equation but we apply a transformation on it. We apply a transformation on it and then we make the output fall between 0 and 1. We constrain the output of the linear regression line. Okay, we constrain the output of the linear regression line between zeros and ones, and that function is known as logistic response function. Okay, and it goes like this: probability of y is equal to 1 is equal to 1 divided by the linear regression line, basically. Okay, this is your logistic response function. It gives you the probability of y is equal to 1. If I plot this on a curve, it looks like this. Okay, it looks like this. You have probability of y is equal to 1 here. This is 1, this is 0. So you see it always lies between zeros and ones. It will never go outside this. And what is on your x-axis? What is on the x-axis here? Yes, guys, what is on the x-axis of this plot? Y-axis is probability of y is equal to 1. Yeah, x-axis is the linear regression line, basically. Okay, so this line. So positive betas, they take you towards 1. Okay, if my beta is positive, I will go closer towards y is equal to 1, right? And if my beta is negative, I will go closer towards y is equal to 0, right? Because if my beta is small, I will go towards that side, right? From this figure, if my beta is small, I will go towards this side. But if my beta is large, I will go towards this side. And if I go towards this side, I have more ones here, right? My ones are here and zeros are here. So this is the interpretation of this curve, the S curve. Okay, if your beta is positive, you move towards probability of y is equal to 1. If your beta is negative, you move towards probability of y is equal to 0. Okay, so imagine your beta is here. So what is the value of y here? The value of y is almost 1. And what if your beta is very small? Here the value of y is almost 0 because this curve is coming here. Right, guys? Okay. So this is your logistic response function. What else did we see? We also saw the concept of odds we saw. So odds is probability of y is equal to 1 divided by probability of y is equal to 0. Right? So after we substitute this equation here, we will get e to the power the linear regression line. Okay. And if we take the odd log of this, we get the linear regression line itself basically. Okay. Log of odds is also known as logit. So this is the theory we saw. Then the output of logistic regression, this y value that we have, probability of y is equal to 1, this is a probability. Okay, so the output of linear regression will be a probability. So what we do in that case is we apply a threshold. We apply a threshold somewhere in between that, and we say whatever is above the threshold. So if probability is greater than t, we say it's a 1. If probability is smaller than t, we say it's a 0. So we apply this threshold, and this threshold is determined based on our business requirement. Based on our business understanding, we determine this threshold. We will see there are ways to determine the threshold from the data also, but ideally it should be determined from your business understanding. We saw the example yesterday. So basically we make some errors and we make some correct predictions. So which error do you want to minimize? Based on that we vary our t. Okay, so let's discuss that now. How do we evaluate our logistic regression model? So how evaluation, let's see that. So we evaluate by using the confusion matrix. Yeah, so we prepare the confusion matrix where we have the actual values on one side and we have the predicted values. So we prepare a two-dimensional matrix and we basically count these values. So this will be our true negative, this is true positive, and then we have false positive, false negative, false negative. Okay, so these are the two errors that we are making. Now we will vary our t depending upon which error do we try to minimize. Do we want to minimize false positive or do you want to minimize false negative? Which one do you want to minimize? Okay, you vary your t based on that. So imagine your probability is to be between 0 and 1 and you have your t somewhere here. This is your t. So you basically vary this t from here to here, you can vary. Okay, and you have some predictions here. So these points are your prediction. So false positive means actually it's a 0 but you are predicting it's a 1. So for example, in what Vinod sent yesterday in the group, so you tell a man that he is pregnant basically, right? That example. So that is a false positive. And false negative is when a lady is pregnant but you tell that she is not pregnant. Okay, that is a false negative. So which error do you want to minimize? Based on that you will vary your threshold value. Okay, so type 1 error. So type 1 error is when you make this error. Okay, this is your type 1 error, false positive, and this is known as your type 2 error, false negative. So which error do you want to minimize? Do you want to minimize your type 1 error or do you want to minimize your type 2 error? Based on that you vary your threshold. Okay, so for example, in the cancer example that we saw yesterday, where you want to identify cancer, we try to minimize the, which error do we want to minimize in case of identification of cancer? Yes guys, which error do we try to minimize? False negative, right? We try to minimize our false negative. So we try to minimize type 2 error in case of a cancer. We try to minimize type 2 error. But in the example which Vinod gave, detection of pregnancy, there we will try to minimize type 1 error. Obviously you will never want to say a man that he is pregnant, right? So type 1 error you will try to minimize in that case. So it depends totally on the problem at hand, which error you want to minimize. And it is very difficult to minimize both the errors. Okay, It is very difficult. If you try to minimize this, the other will increase. If you try to minimize type 1 error, type 2 error might increase. So there is a trade off, and it is very difficult to predict minimize both. So based on the business requirement, we try to minimize the one which we are interested in. Okay. On what basis we say that it is type 1 or type 2 error? There is no basis for this. They have just named it type 1 and type 2. Just some nomenclature they have given, because otherwise it becomes difficult to remember, right? False positive, which is false negative. So they just called this one as type 1 and this one as type 2. Just a name they give. I don't think there is any basis on that. Okay, Brian? Okay. What else did we see? Okay, yeah. We also saw overfitting. So we saw that if your model is very complex, it might overfit the data. So how do you know whether if a model is overfitting? How will you identify if a model is overfitting? Too complex, but how would you know it is too complex? Yeah. So Bharat is right. We will compare the accuracy of training data as well as test data. No, we know the outliers cannot tell you, right? Outliers cannot tell you whether it is overfit or not. Okay. You have to compare the accuracy of both training and test. If you have a very high accuracy on training but low accuracy on test, that means it is overfitting, right? If it is approximately same, that means you are okay. But if your accuracy is high in training but low in test, that means you have overfit the data. And if it is low at both places, that means your model is underfitting. It is a bad model. Okay. So the graph will look something like this. It will look something like this. This is your number of, this is your, let's say, not number, let me make it. This is your model complexity. If this is your model complexity, this is a simple model. Here, this side you have a complex model. Okay. And this is your, let's say, accuracy. For the test data, it will look like this. Initially, the accuracy will be low because your model is very simple. Okay. Your model is very simple, so your accuracy is low. As you increase the model complexity, the accuracy will start to increase because you are getting better and better at building a model. You are building a better model, so the accuracy increases, but after some point it starts to decrease because you have built a overly complex model now. Okay, you have built a very complex model, so it starts to decrease and it falls. But for the training data, it might increase. So for the training data, initially it will be low because the model is simple. It might increase for the training data. Even after this, it might increase. Okay, it might go like this. This is for the training data. So this is your area of overfitting, and this is your underfitting. So underfitting is when your model is simple. Okay, just remember that. Okay. So this will help you decide whether your model is overfit or not. Comparing the accuracies of training and test data. Okay guys, this is clear? Okay. Now in case of linear regression, your model complexity is measured by, how do you measure model complexity in case of linear regression? By the number of independent variables that you have, right? If you have too many independent variables, it is more complex. Same is true for logistic also. The same is true for logistic also. If you have too many independent variables, it means your model is complex. So logistic regression is very similar to linear regression. Okay, all the output and all will come in the same way. You will get p values for logistic regression also. The same hypothesis test will be going on in logistic regression as well. We will see that. Okay, so this is on overfitting. What else, guys? Anything else we saw yesterday? I think no. Okay, so let's start with today's topic then. So today will be more of a hands-on. So let's open our Jupyter notebooks, everybody. Let us open Jupyter notebook. It takes a long time to start. Okay, so I'll open up a new notebook. Okay, have you guys also opened up a new notebook? Okay, great. So just give me a minute. I'll look for some data set. Okay, let us work on Titanic dataset. I think you have done it already. Titanic data you would have used in the first homework that I gave you, right? So we will try to use linear regression, logistic regression there, because it is a classification case. You remember the data, Titanic data set, what we had the dependent variable, whether the passenger survived or not. Okay. And the independent variables were the name of the passenger and other details. Okay. So I think you already have the data, right? You guys already would have the CSV file. Or if you don't have, you can import it from this package. So this package has the Titanic data, py data set. Okay, so you can use this package to get the data out. But py dataset, I think you'll have to install first. I don't think you guys would have it installed. So write pip install, then the package name. This you'll have to write in the command prompt. Okay, in Anaconda command prompt or on CMD command prompt. You'll have to write this on the command prompt and then run this codes. Okay, and then if you see Titanic, it is a data frame which has all the details. Okay, uh, CMD, you go to CMD and type run. Okay, okay, sorry, not run. On CMD itself, you will type pip install. Here you write pip install this particular line, py dataset. Anaconda CMD also works. I think it should work in both. Or if one doesn't work, try on the other. Then you will see something getting downloaded. So just write pip install py dataset. Enter. You will see something getting downloaded and it will work. After that, you run these two lines on Jupyter Notebook after you have installed it. So it says requirement already satisfied for me because I have it installed already. Okay, but you will not get, you will have something getting downloaded. So now let us have a look at the data, how it looks like. Let us see the first few rows. So this is how it looks like. So it is a simplified version of the same data. Okay, it is a simplified version. So you have just three columns. You have the passenger class, you have the age of the passenger and the gender of the passenger. Okay, but this data they have simplified is too much. This will be too small. I was looking for something bigger. Just give me a minute. Sabuddin, there are different packages have different data sets, so you cannot get all the data sets at once. Package wise, you will have to search package wise. So which package has how many data? You can just Google data sets in Python. You will get the codes for it. So each package will have a few data sets. So each package wise you can search. So guys, I have mailed you one data set. We will use that data. Okay. Just check your mails. So check your mails. I would have mailed you one data set. It's called quality. We will use that data. So let's get rid of this. We don't want the Titanic data set. So I'll just import the files which I feel would be required. So I'll import NumPy. I'll import pandas. Yeah, for the time being, I'll import maybe matplotlib. We won't be using matplotlib today. These two should be enough. You know, it is just importing NumPy and pandas, nothing else. Okay. So guys, import the two files and then old codes is not required. You can ignore it. We won't be using the Titanic data, so that is not required. So let's read the data which I have sent you. So I will use pandas dot read underscore csv. Give the name of the file. The name of the file is quality.csv. Okay. So read the file. Do the first analysis of the file. So look how the file looks like. Do a basic summary of the file. So whatever we initially do when we import a data, can you guys do that so that we will have a understanding of the data? Okay, guys, have you read it? Have you read the file? Okay, great. So how many rows, how many columns do we have? Okay, so we have 131 rows and 14 columns, right? So let me also do a quick, so I can write df dot shape. This will give me the number of rows and columns. I can also see the info, the basic info. It will tell me, it will also give me missing values. So I have 131 rows and I have 131 non-null values. So I don't have any missing values in my data, right, guys? I can look at the summary of it. Oh, no, no, no. This is, I wrote R's function. So df dot summary. Okay, it was not summary. I think it was describe. Df dot describe will give me the descriptive statistics of all the columns, right? Yeah. So this will give me, so for member ID it doesn't make sense. Member ID is just an identification variable. Okay, that is just an identifier. So we can also have a look at the first few rows. So if you look at the first 5 rows, this is how the data looks like. So member ID is just a serial number given to the, so this data is from a hospital. Okay, this data is from a hospital. The hospital, based on these variables, wants to know whether a person is, whether a person is receiving poor care or good care. Okay, so the output is poor care. If you see here, the output is poor care. Poor care 0 means he is not receiving poor care. Okay, and poor care 1 means he is receiving poor care. So the idea behind this data set is, the hospital, based on previous patients, has figured out that some patients were not given good care at the hospital. So imagine this to be an audit on the hospital. Okay, and it collected all the other variables based on how many days was the patient in the hospital, ER visits, how many ER visits did he make, how many office visits did the patient make, whether the patient was on any narcotics, and how many days since the last visit of the patient. Okay, then whether the patient was in pain, the total number of visits of the patient, and other way, medical claims, did the patient claim any medical reimbursement, and so on. Okay, so poor care 1 means the patient is receiving poor care. Okay, so why the hospital would be interested in knowing this is because, is that if the hospital identifies that the patient has received poor care, it can take preventive measure. Okay, it can take preventive measure, and it can basically give extra care to that patient. If the hospital realizes that the patient is receiving poor care, the hospital can intervene basically. Okay, so that is why this data set was used. Okay, so let us see now. Vinod, you are saying something? Okay, so now let us go. So I won't be splitting the data. Do we want me to split? Okay, let's see. So now let us begin with, so we won't be doing any EDA or anything on this data. Okay, so this is a simple, you already know how to do EDA and everything. Okay, so plotting each of the columns one at a time. So all these things you already know. We will be doing that during the case study. When we do the case study, I will share a video with you guys, or maybe we can do it live also. So let's see, if I get a good data set, we can do it live, and then we will do a case study and we will analyze this data from end to end. Okay, I have already shared a case study for linear regression, so make sure you guys go through that. Okay, it's a 4 hour long video. It goes in a data set in details. Anybody went through it already, the case study which I shared for linear regression? No? Guys, please go through it. It is very important, okay? So that is most important. So first thing in this week, in the coming week, what you have to do is maybe by Monday or Tuesday, you go through that 4 hours of video. That is very important, okay? Only after that you do something else. That will give you a complete picture how things run from end to end. Okay, so now let us come to model building. So just give me a minute, okay? So before model building, what we can do, we should first see how many, what is the distribution of our dependent variable at least. So how many ones do we already have in our data, right? Let us look at that. So which function do you think will tell me how many ones are there in my dependent variable and how many zeros are there in the dependent variable? Which function will give me that? So for the dependent variable, yes, cross tab. Cross tab gives when you are comparing two variables. That will give you the confusion matrix. I want just one variable right now. Cross tab might give for one variable, you can try, but I think it gives for two variable at least. It takes two inputs, not one input. So which variable will then give? Yes, Anish, you are right. So what about the others? Which variable do you think will give? Have you guys heard of a function called value underscore count? Yes, that will give. Okay, so let's use that. So I'll select the data frame. Then I will select the variable that I want, which is poor care, and I will give dot value underscore count. This should give me how many zeros I have in my data and how many ones I have in my data. Oops. Dot value underscore count. Counts, I think. Yeah, it is value underscore counts. Okay. So I have 98 zeros and 33 ones in my data. So out of 131, 98 people received poor care, did not receive poor care. So we are trying to find poor care. So 98 people did not receive poor care and 33 people received poor care. Okay. So this is what we will try to run a logistic regression on this and see what we get. So cross tab I don't think will work, Vinod. It takes two inputs. Okay. Now remember how we used to run linear regression. So let me do one thing. Let me open up linear regression also, so that we can compare the codes. It is very similar to linear regression. So I'm opening up a small example of linear regression. Okay. And I'll go to the code where I have started the modeling part. It is here. So see, what did we do in case of linear regression? We used from sklearn.linear model import linear regression, right? Now see what we will do for logistic regression. we will use this. So just ignore this for the time being. Okay, this is linear regression only. So for logistic, what we will do from sklearn, we will see from sklearn dot linear model import logistic regression we will do now. So just instead of linear regression, you will write logistic regression. Otherwise, the code is the same. Okay. So let's do this. We will use logistic regression now instead of linear regression. Okay, are you guys following? Okay. After that, the same thing. You will basically you will create an object. So similar to what you did previously, you used to create an object. So you have to split also. So I will come to splitting. After that, you created an object, right? And then you passed your x value and y value from the training data, right? So this is what we will be doing. The same thing we'll do again. So I have imported logistic regression. Now I will create an object and then I will pass my x train and y train values. So let us first we'll have to create your x train and y train. Okay guys, I think you can do yourself now. You already know what you have to do. So before this I'll have to create what is x train and what is x. So x train will be, first let me create x test. Okay, first I'll have to split. So for splitting we will use the same code, import sklearn. I'll just copy paste this from the linear regression part. Okay, and I'll change the value of the variable. So from sklearn.cross validation I will import train test split and then I will split the data into two parts. Okay, so my data is called df now, and let's say I will not keep all the columns as my dependent variable. Okay, I'll take only some of the columns. So first let me see what are the columns. So these are the columns. Let's say I will select inpatient days. Okay, I will select inpatient days and let's say medical claims, medical claims and total visits. These three variables I will select as my independent variables. I will not take all. I will select only these three variables. Okay, I will select only these three variables and my dependent variable is poor care. So I obviously have to select that. I will select my poor care also. Okay guys, are you following? And then test data size is let's say 20%. I will take only 20% data as my test data. So random underscore state is equal to let's say 1. Oops. What mistake am I making? X train, X test, Y train, Y test. I have given my training data. I have given my, okay, this is data. I have to make it data frame df. Test size is equal to this random underscore state. Now this should work. Okay, so I have splitted my data into 4 parts now. One is your training data, one is your test data, and within training and test I have exclusively told which is my x, which is my independent variable, and which is my dependent variable. Which are my independent variables? I have taken only 3 independent variables for the time being. I haven't taken all the independent variables, only 3 I have taken, and I have taken the dependent variable. Okay, I have split into 80-20 ratio. Now I can go and fit my model. So I can take this object and dot fit. I can write x train and y train. Guys, are you following? Y is in smalls. Okay, so this is done. My modeling is done. It's as simple as that. So my modeling is done. I can now see the output. I can make a prediction and I can see the output also. So I'll again go back and copy paste the codes. So I'll make a prediction on my test data now. So log reg, I'll take the object which I created for logistic regression and I will use the predict function on that, and I'll give the independent variable as input and I'll run this. So all my predictions will go inside pred. Okay, oops, and if I see my pred now, so my pred, you can see they are zeros and ones because it has made predictions zeros and ones. Okay, so if you want you can try some other variables also, there is no limit. Okay, I just chose randomly 3 variables. You can choose more or less also. Yes, guys, any doubts, tell me. So did you reach till here? You have made a prediction. Anybody who reached till here? Okay. So now we discussed that we get probabilities out, right? But we are getting zeros and ones here. So how many ones are you getting? Just 2 ones, right? 3 ones. Okay, one. Okay, I got only 2. That's okay. You might have taken some other independent variable. Or your random split, this number you would have given a different number. So your random split will be different than mine. Okay, so answers will vary for everybody if you are using a different random state. Okay, instead of 1, if you are using some other number, your answer will be different. Okay, or if you are using some other independent variables, then also the answer will be different. So don't worry about the answers, we will see that later. But right now, this is the output that you got, right? So this, let me write it down. But Vinod, you might have used some other independent variables, not the ones which I used. Not these three independent variables. You might have used some other. Then why did you get three ones? You should get two ones then. See, I have got two ones. One here and one here. Uh, Run it again. I don't think that should happen. You should also get two ones. Oh, it's okay. That's not a big deal. We will see that later. So let me just write it down. So to get the output as ones and zeros. So this is your output, okay? Now what if you want probability as the output? So here the output is already zeros and ones. Why are you be getting zeros and ones? We discussed that logistic regression gives probabilities as the output, right? Not zeros and ones as the output. So here what is done is by default it has taken a threshold of 0.5. So this is by assuming t is equal to 0.5. By default it assumed threshold as 0.5, and it has basically segregated the probability into zeros and ones. Okay, so this is what it has done. Now let's say you want to override this and you want to get the probabilities out. So for that you can use another code. Let's say I'll call it pred1. You can write the object name log underscore pred log underscore reg logistic regression dot predict. So you see, the moment you do this, you will get this third one. This is what you have to select. Predict probability. This will predict the probability for you, and same input you will pass. X test. Now if you run this, you will see it has predicted probabilities. Instead of ones and zeros, it will predict probability. Right guys, you see this? So for all the test data points, it is predicting probability now. Okay. So why two probability? One is the probability of y is equal to 1. One is the probability of y is equal to 0. Okay. So the first is okay, I think it is reverse. The first is the probability of y is equal to 0. And the second is the probability of y is equal to 1. Okay. Yeah. So this probability is the probability of y is equal to 0. This probability is the probability of y is equal to 1. And you are getting probability for each observation. Are you guys following? Sure, sure, Shahabuddin. Okay. So what did I do? I just imported my logistic regression, same as linear regression, but instead of linear regression, I wrote logistic regression. Because it is always in increasing order or alphabetical order, you can say. So first 0, then 1. Okay, it is always in that order. First you get 0, then for 1. So I imported my logistic regression function. Then the same way I used to do for linear regression, I have defined the object with this function. Then I split my data into two parts, training part and test part. This is the typical format that is used. You use the same format for your linear regression also, and for all other algorithms you will use the same format. Okay, this format will not change. You will just change your dependent variables and independent variables. You will give how much data you want in your test data. So I want 20% of my data in my test data, and you give a random state. Then you fit your model. So while fitting the model, you pass your independent variable of training and dependent variable of training. So when you do this, your equation is basically finalized. Your training is over. Here your training is over. Okay. Okay, that's why maybe, yeah. You gave 30 as your test data. That is okay. Okay. So I created my, so here my training part is over. My equation is finalized. Now I will use the equation, I will use the model to predict. So log underscore reg is the name of my model. I will use log underscore reg for prediction now. So same function, I will use dot predict function, and I will give the independent variable of test data now, because I have to predict for the test data. So when I use dot predict function, it gives me zeros and ones. Okay, it gives me zeros and ones instead of probability. That is because this function dot predict function takes 0.5 as the default threshold, and it converts the probability to zeros and ones. Okay, so predict function takes 0.5 threshold as default and converts the probability to 0 and 1. If you want to give your own threshold, let's say if somebody wants to give 0.4 as the threshold, then he can get the probability out and manually apply his own threshold also. Okay, so for to get the probability out, you will use same predict underscore prob a function. Okay, so predict underscore prob a, this will give you the probability out. It will give you the probability of both 0 and 1. See, the total is 1. This is the probability of 0, this is the probability of 1. Now you can select the probability of 1 from here and divide it into zeros and ones, segregate it to zeros and ones, applying your own threshold. So how will you do that? Let's say you want to give a threshold of 0.4. So let's apply our own threshold. Okay, so how will we do that? First we will select the probability of y is equal to 1. Why are we selecting probability of y is equal to 1? Because in the equation of logistic regression we have probability of y is equal to 1. That is why we have to select this always. Okay, so I will select probability of y is equal to 1. How will I do that? Now pred1 has both. Okay, so pred1 has both, and it doesn't have column names also. So how will I select? So let's see the class of pred1. What type is it? So this is an array. So in the array we have to select the second column. So how will you select the second column from this array? So how will you select the second column from this array, guys? I want to select the second column, and the column does not have any name. Yes? Anybody? So I have an array here. See, it says array. I want to select the second column. Yes, the ilog function. Yeah, you can use the ilog function for it. So ilog, and you give the second column, right? So you want all the rows and you want second column. Oops. No, you will give 1 as the output. The indexing starts from 0, right? No. No, what was the syntax, guys? So you give, okay, I think it requires you to give this. No? What if I give this? No. This should work. So pred.ilog, what if I remove the ilog and I give just this? No. Yeah, I think ilog is only for data frames. I want to select the second column out of it. Oh no, it is not from NumPy. It is, yeah, it is for data frame. That is why it is not working. ilog is only for a data frame. So there must be a way. Let me think of it. You guys also try. Think. If I give this, okay, this is giving me, so let me give 0 here. This is giving me 0 till the end. No, Vinod, cross tab will not work here. We don't want a matrix out, right? We want a list out. We want a one dimensional array out. When you want a two dimensional array, we will use cross tab. Okay, so this will work. So I was not giving this 0 actually. Yeah, so this is slightly different than R. So I'm comfortable with R as well. So in R, what do we do if we have to get these out? We will just leave it blank and we will write 1. So blank means it will print all the rows. But in case of Python, you can't leave it blank. You will have to write this. You'll have to write this colon here. Only then it will work. So right now you see it is giving 0.1091469. So 1091469. So only then you will be able to filter it out. Okay, so this is how you do it. So iLock only works with data frames, I guess. Yeah, so iLock only works with data frame. It doesn't work with arrays. Okay, guys. So I have selected all my probability of y is equal to 1. Now I can compare it with greater than equal to, let's say, 0.4. So I can write, let's say, another variable. I can create another variable. Let's me call it, let's say, x is equal to spread 1 is if it is greater than this. So I can use if condition for this. If which is greater than this, then I will write I can use a comprehension. I think that will be better. So x is equal to 1 if spread 1 is greater than 0.4. Okay, else 0. I can use this. Oops. 1 if spread of this is greater than else 0. Okay, I think I'll have to put a variable also here. Hmm. I don't. Why did I write 2 if? 1 if spread of 1 is greater than 0.4, else 0. No, there is no variable here. In comprehension, we usually give something which iterates over again and again. So let me do one thing. Let me create a new column and insert this value there. So I'm creating a new column called predicted. Okay, that will be equals to 1 if my spread of this is equal to. Hey guys, you also try to convert this to zeros and ones. Try and tell me if it works. just try on your Jupyter notebook. Okay, guys, try and see if it works, then you tell me. I think this should work. The truth value. Okay. Yeah, so this worked. Let me see now. Yeah, this has worked. Okay. So you got only one. What does that mean, Vinod? You said you got three ones, right? Previously. So I used a loop to convert it to zeros and ones, but I think there should be a better approach. So this worked, but I think there should be a better approach. No, no problem, Vinod. So your model might be different. That is why you are getting a different answer. That is fine. That is fine, Vinod. Your model must be different, so you are getting a different answer. Yeah, that you can use, but you can use pred 1. So what have you used? You have used is greater than equal to 0.4. Yeah, this will give you true false. You can use this also. But this will give you true false. You have to convert it to ones and zeros. Okay. So you can use this also, but this will be true or false. And you can then convert it to ones and zeros. So I think if else should be if. Yeah, but this won't give you ones and zeros. So you will have to figure out a way to convert this to ones and zeros. Okay. So it is true and false. So that is okay. I think what we were trying to do, this worked, but there should be a better approach. So maybe I'll think of it, and if I find a better approach which does not use a loop, I will try to post it to you guys. Okay. But right now I have, so how many ones did I find? One, two, three, four. Four ones I found. Okay. Four ones. Right, guys? How many ones did you get when you used a threshold of zero point 0.4? Okay, Vinod got only 1 1. What about the others? Okay. So if your codes are exactly same as mine, you will also get 4 1s. But if you have made any differences either in the random states value or in the independent variables that you have used, your values might be different. Okay. So now let us go to the confusion matrix. Okay. Let us go and see how do we create the confusion matrix. So let me get rid of this. So now I will use the pd.crossTab function. So first let us do with this pred. Then we will do with pred1. Okay. So let me just take out pred1 for the time being. Okay. So my pred has only ones and zeros. I will create a confusion matrix now. So I'll create the confusion matrix. I'll use the pd.crossTab function. Okay. So what will I find? What will I do? In my confusion matrix, I have the actual values on the left hand side, right? If you see this, I have the actual values here. So I'll give the actual value first as input. So where are my actual values? My actual values are in my data frame. So data frame poor care. These are my actual values. Okay. And then I'll give my predicted values which are coming here. Then I'll give my predicted values. So my predicted values are inside pred. So pred is the object which has my predicted values. And I will run this. Oops. What is this error? Array length. Okay, I should have taken only the train data, right? Not all the entire data frame, because the output is only on the test data. So I should take the test data here also, right? So I'll have to take the test data only, which is y underscore test. Y underscore test is what I will take. I have created a subset, and then I will run the cross tab. So you see, I will get something like this. So 14 to 11 0. Now I can find my accuracy here. So guys, tell me how many, which is my true positive, which is my true negative, what is my false positive, and what is my false negative. Okay, tell me these values and then we will find our accuracy. Accuracy is equal to, we will give true positive plus true negative, right? Divided by, I will write divided by the number of rows in my train, in my test, sorry. Okay, similarly the error will be false positive plus false negative divided by the same thing. So this is my error on my test data. Okay, these are all my error on the test data. So what is my TP, guys, here? Tell me, which is my TP here? True positive. Okay, so Bharat says 2, 14, 11, 0. What about the others? Which is my true positive? What is the value of true positive here? Yeah. So true positive is 0. This term, right? Yes. So true positive is 0. True negative is this 14. Right, guys? True negative is 14. So Shahabuddin, you also made a mistake, I think. So 14 is my true positive. True negative, sorry. What is my false positive? False positive means actually it was a 0, but you predicted a 1. So this 2. So 2. And obviously 11 remains. So you see your false negative is high. False negative is quite high. Okay, so this is what you get. So this is your accuracy and this is your error. Let us print it now. Print accuracy, and you can also print error. Oops, okay. I think I'll have to convert it to float. It is taking as an integer. That is why it is giving 0. I'll have to convert it to float so that we get in decimals. Okay. 0.0. Why is that? True positive plus true negative. Okay. Let me do it manually once. So 14 plus 0 divided by 27. Yeah, I think it is rounding it off. So I'll have to write float at each point. But that is a pain, right? Something must be there. Yeah, if I write 14.0, it will give, I know. But what about here? I cannot write 14.0 here, right? Okay, in this case, I can write them here. Here I'll have to write point 0, point 0. Then I don't have to write it here. It should work now. Why is this 5? Oh, I made 140. Okay. Okay, so 51% is your accuracy and 48% is your error. Okay, so this is what you get. No, not a very good model. Okay, not a good model at all. Right, guys? So try something and try to make this model better. Now let's see how well we are doing when we took zero point 0.4 as the threshold. Let us see that. Okay, so I'll just copy these same things and I will paste it here. Okay, I've already mentioned it. So this will give me my probability. Then X will have my ones and zeros now. Now I can prepare the same crosstab. I'll copy the codes. I'll prepare the crosstab Y test. Now it will be pred. Instead of pred, I will write X here. Okay, I will write X. Oh, why am I getting this? So Y test is my actual values, but Something is wrong. Just a minute, guys. Something is wrong here. Instead of X, why am I getting this? Did I run this? This one. Okay. Okay, so what I have done is I have taken that X. Now that X is a list. Okay, if you see this X which I prepared here, that X is a list. So what I will do is I will convert that list to an array. I've converted that list to an array and then I have used it in the cross tab function. Okay, after that I have used. So this is what I'm getting now. Now my true positive is 2. Earlier it was 0, right? Now it is 2. True negative is still 14. False positive is 2. And false negative is 9 now. So my accuracy will increase slightly now. So now you see it became 59%. Okay. Slightly it increased if I use a threshold of 40% instead of 50%. Sure, Rekha. Okay, guys. So do one thing. Try to use some other independent variable and try to build a better model. See if you can build a better model. So try to use some other independent variable from among these. These are the independent variables you have. Try to use maybe narcotics or some other independent variable and then try to do. I just took a random value, Vinod. I just took a random value because I was getting very few ones, right? I saw that in my original data. I saw that in my original data, how many ones did I have? I have 33 ones, right? Out of like almost the ratio was almost 25%, right? 25%. It's here. This is where I have taken this one, 0.4, 40%. Okay. So I saw that the ones that I was getting, if I take a threshold of 0.5, the number of ones that I was getting is very small. Only 2 ones or 3 ones I was getting. But actually there are more ones in your data. So I changed the threshold to a smaller value so that I get more ones. Yes, even earlier I had used 0.4. I never changed the threshold. It was always 0.4. But by default, whatever is taken here is 0.5. Here it is by default 0.5 because it already classifies into ones and zeros. Okay, so don't get confused with this. Here we are not taking the probability out. We are directly taking a threshold of 0.5 and converting it to zeros and ones. But here first we are getting the probability out and then we are converting it to ones and zeros by giving our own threshold, which I took as 0.5. Okay. So any doubts so far, guys? Yeah, Kavya, that is the $1,000,000 question in analytics. That is the toughest part of analytics. How do you decide which variable is important? So you decide based on p values. So I have not gone into p values yet. So I'll also talk about p values. So we will see the output just like linear regression, where we get the p values and everything. So we will come to that. So maybe we'll take a break, and after the break, I will discuss that as well. So the p values will help you decide which variables are important, which are not. Okay, just like a linear regression. So you see which p values are less than 5%, you take those variables as important. Okay, any other doubts, guys? Okay, so let's do one thing. Let's take a quick break, and after the break we will see how to get p values in logistic regression, and we will see some other parameters also that is used. Okay, so some parameters which we did not discuss yesterday, we have to discuss that as well. Okay, so let's take a 15 minutes break. Okay, I have got some work actually, so let's take a 15 minutes break. So it's 3:40 now, so let's just resume at 3:55. Okay guys, let's resume at 3:55. Okay, so I will just pause the recordings. Okay, so maybe I'll put a reminder somewhere. Okay, so these are the things we will discuss. So sensitivity, specificity, how to find whether your independent variables are important when your dependent variable is categorical. Okay, and what else we will do apart from p values. So this is apart from p values. This is apart from p values. Okay, okay, so let's see one at a time. So let me think of which one should I start first. So first let us do this one, finding which variables are important. Okay, let us do this first. So let's say I have, so my dependent variable is, categorical, zeros and ones, right? Right guys, my dependent variable is zeros and ones, so I cannot find a correlation. Let's say my independent variable is, let's say, continuous, and I have another independent variable which is categorical. Okay, so my dependent variable has to be categorical if I am doing logistic, right? This has to be categorical if I am doing logistic. My independent variable can be anything. It can be continuous, it can be categorical. So now correlation of the dependent variable with the first independent variable will not make sense because this is categorical. Similarly, correlation of dependent and second independent variable also will not make sense because this is also, because still this is categorical. Because the dependent variable is categorical, these correlations will not make sense. So you cannot use correlation to find which variable is important, which independent variable is important. You cannot find by using the correlation value the way you used to do for linear regression. Okay, so what you will do in that case, there is still a way. So you can draw count plots. So remember we drew count plots while we were doing C-bond. So what are count plots? You can draw count plots of zeros and ones. So let's say this is your 0 and this is your 1. What 0 and 1? This is your poor care basically. This is your dependent variable. Okay, and you will separate them. So I'm talking about the first case here. Okay, the second case, sorry, when your independent variable is also categorical. When your independent variable is also categorical, so at that time you can draw a plot like this, 0 and 1, and you can let's say your independent variable is, which categorical variable do we have? Let me see so that I can explain better. Let me take, let's say we have a categorical variable pain. Pain is 1 and 0. If 1, if the patient was in pain, 0 means the patient was not in pain. Okay, so let's say I have pain and 1 is poor care. So I have these two variables. So what will I do here is, I will plot a count plot like this, zeros and ones, and I will have colors here. I'll have one color for pain. Let's say I have red for pain, and let's say I have green for no pain. This is green for no pain. And imagine I see colors like this. So this entire thing is red, imagine. Okay. Similarly, let's say this thing is red and the others are green. So what does this tell you? So what does this tell you, guys? Yes, anybody? Does it tell you something about the independent variable pain? Yes, what does it tell you? This tells you that most of the patients who were in pain, okay, almost 90% of the patients who were not in pain received good care, right? This is nothing but good care. This is good care, this is poor care, right? Poor care 1, that means this is poor care, this is good care. So what does it tell you? Most of the patients who were not in pain, no pain. So most of the patients who were not in pain received good care. Right? Right, guys? So 90% of the green part is falling under 0. And only let's say 10% is falling under 1. So this means that pain is important. Pain variable is important. So compare this figure with another figure that I'm drawing right now. So imagine the same figure if it was like this. The same figure if it was like this. This is the same figure, okay? This is no pain and the red one is in pain. So compare this figure with this figure. Can you understand that in the first case pain variable is important, but in the second case pain variable is not important. Why? Because here we have a clear distinction between green and red. So 90% of the green is 0. See, only 10% is red. So by default, if you can make a guess, you will say that everybody who is green is basically 0. You can make a guess. But here it is 50-50. You have 50-50 here, 50 here, 50 here. Similarly, 50 here, 50 here. So even if you have some green, you cannot say whether it falls under 0 or 1 because you have equal amount of green at both places. Right, guys? You have equal amounts at both places. So you cannot say that the green will be 0 or the green will be 1 because you have equal amounts in both places. But here you can directly say that the green means it is 0 because you have most of the green as 0. So do you understand? So this is how you can draw plots like this and you can find whether a variable is important or not. Whether a categorical variable is important or not. Okay, by drawing plots like this. Because 90% of your green is basically 0 and only 10% of your green is non-zero. So you can make a guess that whatever green I am getting is basically 0. You can tell that without going to the analysis also. But here you cannot say that because you have 50% here and 50% there. You have equal amount there. So it is 50-50 basically. You may go wrong 50% of the times. But here you will go wrong only 10% of the times. So this is helping you find that pain is important. Understand, guys? Did you understand this? So we can draw charts like this to basically find out whether the variable is important or not. So this we did when both were categorical. Both our dependent and independent were categorical. Similarly, you can draw for continuous also. So for continuous, you can draw histogram and you can give color to your histogram. So let me ask you now. Let's say I draw this and I get a color like this. Let's say this is all green, and I draw another plot where I get this as green. Okay, this is green here, this is green, and the remaining is red, of course. Okay, oops. So this is green and the other part is red. Okay, and let's say green means pain. No, green is your poor care. Okay, green is your poor care and red is your good care. Okay, this part is red. And what is this on the x-axis? On the x-axis, you have some independent variable which is continuous. Okay, only then you can draw a histogram, right? So this independent variable is continuous. Same for this. Both are same basically. So which histogram tells you that that independent variable is important? Which histogram tells you? The first one or the second one? Okay, Aurangzeb says second. Abuddin also says second. What about the others? Think and tell, guys. Think about it. Okay, Anish says both. Bharat says first one. Okay, so let me give you the answer. Okay, answer is second one actually. The second one is better. See now, let's say imagine this independent variable to be age. Just imagine it's a continuous variable, so imagine it to be age because age is more interpretable. You can understand and relate better. Okay, so you have age here. So let's say the age is starting from, let's say, somewhere 10. It goes till, let's say, 80. Here also it is 10. It goes till 80. Okay. So if somebody is, let's say, 15 years old, can I tell whether he is receiving poor care or not based on this figure? If somebody is 15 years old, can I tell 15 is coming somewhere here, right? Can I say that he is red one or he is green one based on this figure? Guys, if somebody is 15 years old, can I say? So 15 years means it's coming here, right? It's coming here. So it has both green and red, right, Rekha? So how can you say that it is green or it is red? Because both red and green are here at this point. This is 15. You have both green, so this is your red and the remaining is green. So it can fall anywhere. So there is a confusion. You might go wrong, you might go right. Similarly for all other regions. Even if you take, let's say, somebody 50 years old, even here you have some red and some green. So you cannot be sure. So this figure will not help you explain your output variable. But come here now. Let's say you are 15. So 15 you have all red. All red. So you can say with 100% confidence that if somebody is 15 years old, he must be red. Because you have only red here. Similarly, beyond this region, let's say this is 60. So beyond 60, you can say with 100% confidence that if it is 65, it must be green. So the second histogram is helping you identify your dependent variable directly. The second histogram is doing that. The first is not helping you. Okay. Understood, everybody? So these two concepts, the first one, which was for two categorical variables, the second one, which was for categorical and continuous variable. Okay. So we have seen all the ways to find important variables. Okay, these things are very important and you will not find this in any book. You learn this by experience. Okay, this is not present in any books. Find variables which are important. So how do you do that? Number one, when your dependent variable is continuous and independent variable is also continuous. This is simple, right? This is simple. you just do a correlation between the two, right guys? You get a correlation between the two. If they are highly correlated, you say that that is important. Now the second case, your dependent variable is continuous and your independent variable is categorical. Your independent variable is categorical, your dependent variable is continuous. So how do you do this? The second one, this one. Okay, this will come into picture. You draw a histogram. You draw a histogram here. Okay, now the third one. Third one, dependent variable is categorical and independent variable is continuous. Okay, again the same one. You draw a histogram here also, the same figure. Okay, this applies to both case. And the fourth one, the dependent variable is categorical, independent variable is also categorical. You draw the other one, this one basically. This count plot is what you draw, because you cannot draw a histogram in this case, right? Because both are categorical, so histogram doesn't make sense. All you can do is count plot. You can only do a count plot here. You cannot do anything else. Okay, so these four methods you can use to find which variable is important, which is not, even before going to your modeling stage. Okay, even before going to your modeling stage. Okay guys, so this is known as your, so there are specific names given to these techniques. Okay, this is known as your chi-square test. This is your chi-square test in statistics. Okay, this is your correlation. This is correlation. This is your z-test. This is your z-test. And this is your t-test. Okay, this is your z-test. This is your, don't worry about these a lot, but this is how it works. Okay, these are the statistical terms for it. So that is why, if you remember, okay, I think I interchanged this. This is your, yeah, it is correct, I think. So that is why, if you see here, the output that we got, we are getting z values here, right? If you remember in linear regression, if you see, let me show you linear regression. Here we were getting t values. See, here we are getting t values, but here we are getting z values. So the test is different, but it means the same. No matter which one you use, you will get the same output, but it changes slightly. Okay, so both of these are similar, where you do x minus x bar by sigma. This is what you do in both cases, and then you fit it in a, so in this case you will fit in a t distribution, in this case you will fit in a normal distribution. Okay, this is a t distribution where you have a gap here. Here you don't have much gap, it almost touches. Okay, it almost touches. Okay guys, is this clear? So we will do this. So the case study which I have shared with you, right guys, the case study, the 4 hours which I shared last week, that has an application of all of this. See, these things takes a lot of time. So if I start doing this one by one for all the independent variables, it will take the entire class, so we will miss out a lot. That is why I have already recorded those videos. I did it in a different class, and I have shared it with you, so that you don't lose out on that. Okay, so please make sure you go through that video also. Okay, and that video also talks about dummy variables, which is important, which I'm not covering because I'm expecting you to learn it from that video. It is very easy concept. Okay, so I want to devote my time to something else, so that easy concept you can learn on your own, and I have given you the time also, in which time is that concept coming, so that if you don't want to go through the entire video, just go through that particular time duration. I think it is 10 or 15 minutes in that video where I'm talking about that dummy variables. Okay, okay, so this is done. This is done. Now let us talk about baseline method. Let us talk about baseline method. So who remembers about baseline method? Anybody remembers what a baseline method is? We have seen it in regression, by the way. So what is the baseline method in case of regression? Guys, you agree with Aurangzeb or you agree with Jasmilla? Yeah, Jasmilla also says the same, right? Yes, that is correct. When your prediction is the average, that is the baseline. That is known as the baseline method, right? When you predict the average. So SST that you saw, remember R square formula, it was 1 minus SSE by SST. This was coming from a linear regression model and this was coming from a baseline model, right? Correct, guys? So that is in case of a regression. That is in case of a regression. Now we are dealing with classification. Now in classification, what do you think can be the baseline method? What can be the baseline method in classification? Because we don't have a continuous variable, so the mean will not make sense now. You only have ones and zeros. So the mean of these doesn't make sense. So what will you say is the baseline method then? Think. Okay. So the question is basically, let me put it in another way. Let's say I give you the income. The dependent variable is income. And I tell you the income of, let's say I have a class of 10 students, 10 professionals who are working. I give you the income of 9 of them. Okay, let's say I write it here. Okay, I give you the income of these many guys, and the last guy I don't give you the income. And I ask you what is the income of this last guy. I don't give you any other variable. What will you tell me? What is the income of this person? You will tell me the average, right? So this is the baseline method, right? This is the baseline method which tells the average. Now this is a case where the dependent variable is continuous. Now uh, let me give you another variable which tells, let's say whether this professional has a car or not. Yes or no. Okay. 1 means he has a car, 0 means he doesn't have a car. And these are the values. So 1 0 1 1 0 1. These are the values. And for the last guy I don't give you. Now what will you tell me? You can't tell me the average, right? It wouldn't make sense. Average you will get some point zero something. So what will you tell? That this guy has a car or not? What will you say? Yes. You will tell the mode. So what is the mode here? So you have one, two, three, four, five. 5 ones you have. And how many zeros you have? One, two, three. You have 3 zeros. So most of the people here they have cars, right? And a few don't have cars. So what you will predict is that this guy also probably would have car. Right, guys? Yes, so this is the baseline method for classification. This is the baseline method for classification. Yeah, if it is 50-50, you can't do anything. You will be confused. Okay. If it is 50-50, you can't do anything, Bharat. Okay. But you always predict the class which is present more number of times, or which is more in proportion. Okay. The class which is more in proportion, you predict that. So that is the baseline method in case of classification. In case of regression, it is the mean. But in case of a categorical variable, your baseline method is the mode. Okay, here one is the mode. So whatever we do using logistic regression. So similar, what were we doing here when we used R square? We were trying to compare our output with respect to the baseline method, right? R square was a percentage, for example, 80%. So 80% means how good is this with respect to a baseline. So similarly in logistic also we will try to be better than the baseline method. Better than baseline. So we will create a confusion matrix for baseline method, and we will also create a confusion matrix according to our logistic regression. And this should be better. If this is not better, then this is a waste. This is not at all a good model. Okay, it should be better than a baseline model. So what will be the confusion matrix of this? Let's create the confusion matrix of this baseline method. So let me write the actual value. So actual value I can write 0 and 1. And what is the predicted value? What is the predicted value for this model, for the baseline model? Yes, guys, tell me. The predicted value is always 1, right? You always predict 1. No, it is not 0. You will never predict 0. Just now you told, right, that you will predict 1. You will never predict 0. Because you don't know which one is 1 and which one is 0. So you will predict always 1. So you will not have 0. This will not be there. Only 1 will be there. So this will be 0. This will be 0 for you. Because you are not predicting any 0. You are only predicting 1. Now you will see how many were actually 0. Actually 0 were 3. So this number will be 3. How many were actually 1? 5. So this will be 5. So your true positive is 5. Okay. And your true negative is 0. Because you did not predict any 0. So what will be the accuracy of this? It will be 5 divided by total. 5 divided by 8. This will be your accuracy. Okay. This is the accuracy of a baseline method. So this logistic regression should beat this 5 by 8. If it is better than 5 by 8, you are good. But it should not be worse than this. Okay, guys? Did you understand? Okay. So that is the concept of logistic regression. That is the concept of baseline method in logistic regression and where it is used. Okay. So baseline method is also done. Now, what is this term? Let us see. So let me create a confusion matrix once again. Okay. So let me write actual and let me write predicted. My actual is 0, 1, predicted is 0, 1. Let me write all the terms once again. So true negative, true positive, false negative. Okay. Now what did we see yesterday? We saw that the accuracy was true negative plus true positive divided by total. Similarly, the error was 1 minus the accuracy. Okay. This was the error. Similarly, we have some other parameters also to evaluate a model. Okay. One of them is sensitivity. Sensitivity. Okay. So what is sensitivity? It is also known as true positive rate. True positive rate. Okay. So what is the formula for this? The formula is true positive. Since it is true positive rate, you will write true positive at the top. Okay. True positive at the top. And what will be the denominator? The denominator is the row total. the row which has true positive. Okay, so it will be false negative plus true positive. This is the formula for sensitivity. Okay, true positive rate, so you write true positive at the top and then you add the entire row. Okay, you add the entire row. This is your sensitivity. This is also known as recall. This is also known as recall. Okay, now what does it mean? What is the interpretation of this? What is the interpretation? What is this denominator? What is the denominator? What do you get when you add false negative and true positive? What do you get? What do you get here? If you add these two, what do you get? Yes, guys, if you add these two terms, what do you get? You get the total. No, total is all this, right? All the 4 is total. I'm not adding these two, only these two. Yes, I get the total ones, right? I get the total actual ones. Right, guys? If you add these two, you get this one, right? So what does it measure and what is this TP? The ones which you are able to capture, right? This TP is nothing but your predicted ones. So what does this mean? This means it measures how many ones the model captured out of total actual ones. Okay, how many ones did the model capture out of the total actual ones? Okay, guys, out of the total actual ones, how many ones did you capture? Okay, so for example, we were discussing about the cancer case yesterday, where your goal is to identify if a cancer has if a patient has cancer or not. Remember? So for that case, sensitivity will be very important. Your sensitivity should be high because you have to capture your actual one. This has to be low. This has to be very low, right? This has to be very low and this has to be very high. So this number should be very high in that case. Okay. Understand, guys? Okay. Similarly, there is another term called specificity. So this measures how well you are capturing your ones, okay, your actual ones. Now specificity, it is true negative rate. This is just opposite of this, okay, true negative rate. So since it is true negative rate, I will write true negative at the top, okay. And what will be my denominator? It will be again the row total, this row total now. So true negative plus false positive, okay. This will be my specificity. Now what is specificity? What is the interpretation on similar lines? What will be the interpretation? Now this measures how many zeros did you capture, okay? This measures how many zeros did you capture out of total actual zeros. Out of total actual zeros, okay? So this gives priority to zeros, to capturing zero. How good is your model capturing the zero? This gives priority to ones. How good is your model capturing one? So based on your business statement, you will give priority. You will give priority to sensitivity or you will give priority to specificity. If you want to capture the ones properly, you have to give priority to sensitivity. If you want to capture the zeros properly, you have to give priority to specificity. Okay. And there is just one more, which is called precision. Okay, there is no other word for it, but the formula is, this is similar to sensitivity. The numerator is the same, but now the denominator will be not row total, okay, it will be column total. Okay, it will be column total now. So FP plus TP. So the denominator is FP plus TP now. Now this is column total, not row total. This and this you saw the row total coming as denominator. But in precision you will have the column total coming as denominator. Now what is this term? What is the denominator here? FP plus TP, what is that? What is FP plus TP? The total predicted ones, right? Not 0 and 1. It is only 1. Now you will have to look in terms of predicted. Earlier you were looking with respect to actual. Now you will look with respect to predicted. Because actual will not make sense. Half is here, half is here. But this, if you see, they fall in the same column. So this is the total predicted ones. Right guys? This is the total predicted one. So what can I write here? How many ones did you capture with respect to predicted ones? Okay, with respect to the predicted ones, how many ones did you capture? This is very similar to what I have written above for sensitivity. How many ones did you capture out of total actual ones? Okay, this word is different here, out of total predicted ones. So thus the denominator is changing. Okay, so that is the difference. Okay guys, so you guys are supposed to remember these formulas. Okay, I don't think these will be asked in interviews, but you never know because these are very important. You have to calculate these after running every model. So try to remember, and it's not difficult. Okay, it's not difficult. So if you just prepare the confusion matrix and try to come up with these formulas. And I can change this matrix also. I can write predicted here, actual there, and all those combinations I can do. So you try it yourself. Try to change the matrix and try to come up with these formulas, and then look it over the internet and see if you went wrong or if you are correct. Okay. So what is Bharat asking? The model capturing is equal to predicting variable. Bharat, can you rephrase your question? I didn't get it. So precision is the same as sensitivity, just the denominator is the column total now. This is not the row total. So how many ones did you capture out of the predicted ones? So let's say you say that 10 patients have cancer. Okay. You predicted that 10 patients have cancer. Out of that, how many actually had cancer? That is what you are trying to measure in precision. Okay. So think of it in that way. Okay. Let's see you are a hospital. Let's say you are a hospital. Okay. This is 0, this is 1, this is 0, this is 1. Okay. Now you want to capture all the ones. Okay guys. You want to capture all the patients who have cancer. So what is the best way to do that? What is the best way to capture all the patients who has cancer? So you are a hospital and you want patients come to you for a cancer test. Okay. They come to you for a test on cancer, and so what is the best way to capture all the patients so that you don't miss any patient? What is the best way to do that? Why threshold point 2, Bharat? Where did you get that number? Yeah, but how will you capture that? How will you capture? How will you capture? How will you be 100% sure that I have captured all the patients? I have not missed anybody. How will you do that? Let's say 10 patients came to your hospital. Okay. Yeah, Vinod, but the output of test is in a probability. Okay. So if you have asked, so these big GE machines that you see, right? So go to any hospitals, the MRI scans and so many other stuff are there, right? Which detects cancer. So the GE machines, they also give output as a probability. Okay, that is why I gave this example always. The GE machines, big machines which cost crores of rupees, they will give output as a probability. They never give whether it is 1 or 0. They will give as a probability. Yes, Philips also. Yes, Philips also. And it is up to the doctor to decide. After looking at the reports and looking at the probability, the doctor decides. And looking at the symptoms of the patient, the doctor decides whether it is 1 or 0. So the doctor will set some threshold and he will decide. So the question that I'm trying to answer is, I'm trying to ask is, let's say 10 patients come to a hospital. Out of that, let's say 8 patients have cancer, and you don't know which has cancer, which has not. All are equivalent to you. All 10 are equivalent to you, but out of that, 8 has cancer. Now, how can you be 100% sure that you are correct? You don't want to miss any of these 8. You want to capture all the 8. So, what decision will you make which will capture all these 8? Yes, so Bharat is right. You will say that all have cancer. Simple, right? You want to be safe, so you will say everybody has cancer. That way, you will never miss anybody. Do you agree, guys? You will say that everybody has cancer. All 10 has cancer. So that way, you will not miss anybody. Okay? So you can do that. You will not miss. So what will happen in that case if you say everybody has cancer? So by the baseline, you will go by the baseline method basically. So your ones will be, this total will be 10. And this will be 8. This will be 2. This will be 0. This will be 0, right? This will be your confusion matrix if you say everybody has cancer. That's okay, Vinod. We want to be 100% sure that I don't miss anybody who has cancer. That is why I will say everybody has cancer. So that I don't miss anybody. If you say, let's say 8 has cancer, we don't know which 8. You don't know which 8 has cancer, right? So you might miss the correct guy. So to be safe, you will say everybody has cancer. Okay? So this is what you will get. So, but in this case, what will happen? Your sensitivity, calculate your sensitivity. What will be your sensitivity if you see the above formula? Sensitivity is true positive divided by rho total. Okay, what is your true positive? It is 8. So 8 divided by 10. So 80%. Jasmila, I am not assuming 10 don't have cancer because I'm interested in finding who has cancer. I'm not interested in finding who doesn't have cancer. I'm interested in my ones, not my zeros. Okay. So it depends on your business statement, and obviously you will be, most of the times you will be interested in your ones and not your zeros. Okay. So I have calculated sensitivity now. Yes, it is rho total. So okay, it is 8. Yes, correct. So it is 100%. Okay. So I have calculated sensitivity. It is true positive divided by rho total. Rho total is also 8 because this is 0. I get 100%. So my sensitivity is 100%. Right? I'm 100% correctly identifying the actual ones. So the interpretation you understand now? That is what we discussed, right? The interpretation of sensitivity is how many actual ones are you able to catch? And here I am catching all the 8 people who have cancer, right? So it should be 100% because I am catching all the actual cancer patients. So it is 100%, which is quite good. Now let's see what will be the precision in this case. The precision will be 8 divided by column total, which is 10. So my precision is 80% only. It is not 100%. Okay. So because of sensitivity, what happened? You are doing good. You are doing good, but your precision is not good. Why your precision is not good? Because you are predicting everybody has cancer. So your precision is not good. So you might be caught by the government for being greedy. That you are saying everybody has cancer. So this also is equally important as this. You have to have a good sensitivity, but at the same time your precision also should be high. And there is a trade-off between these two. You cannot be high on both. You can be high only in one of them. Okay. So that is why the threshold value becomes very important. We have to play with the threshold so that we can balance these two well based on our business. Because you can't be 100% here and 80% here. This is not good. Okay, this is almost like a baseline method. You cannot be a baseline method. Okay, guys, you cannot say everybody has cancer. This is totally wrong. So you will have to figure out a way and increase your precision. So this has to be close to 90%. And here you might go slightly low, maybe 95%. That is the ideal situation. And I'm not calculating specificity because I'm not concerned about the zeros. I'm only concerned about the ones here. Yes, so a trial and error has to be done here. Okay, you have to do trial and error here. So now you might ask me, how many trial and error will I make? There can be infinite value of thresholds which I can take, right? I can take I can take zero point 0.5, I can take 0.51, I can take 0.52, and so on. There can be infinite number of values, right? So how should I start? Should I take zero point 0.2 or should I take 0.8? I don't know. So that brings us to something called ROC curve. So ROC curve helps you decide your threshold. Okay. ROC curve will help you decide your threshold value. So what is this ROC curve? The full form is receiver operator characteristic curve. Okay. Don't worry about the full form. Receiver operator characteristics curve. Now what is this curve? So let me draw this curve. It looks something like this. You have sensitivity on the y-axis. Okay. You will have sensitivity on the y-axis and you will have 1 minus specificity on the x-axis. Okay, 1 minus specificity on the x-axis, and it looks something like this. Okay, so it is a two-dimensional plot, but it has three axes. One axis is this, one axis is this, and the other axis will be along this. Along this you will have another axis. So the threshold here is 0 and the threshold here is 1. Okay, so it is threshold is 0.9 here, threshold is 0.8 here, 0.5, 0.4, 0.2, and finally 0. Okay, this is how it goes. So this is your ROC curve, and this helps us determine what is the value of threshold you should take. Now let us see how does this decide what threshold you should take. How will this curve decide that? Okay, so what we do, let us draw the uh, confusion matrix once again. Okay, this is your confusion matrix. Now let's say your goal is to maximize your sensitivity. Okay, imagine so what is sensitivity? Your true positive rate, right? This is your true positive rate. And what is specificity? True negative rate. Okay, true negative rate. So if I write true negative rate, if I write the formula for specificity, it is like this: true negative divided by true negative plus false positive. So it will become false positive divided by false positive, right? If I do this calculation, it will become like this. So this is nothing but false positive rate. Okay, 1 minus specificity is your false positive rate. Guys, are you following? Okay, so 1 minus specificity is nothing but, I just put the formula here and I did this linear algebra and I got false positive rate. False positive has come at the numerator, so this is false positive rate. So this is your true positive rate, this is your false positive rate. So that means one is this, one is your this, one is your this. Okay, now is this good for us or is this bad for us? True positive. Yes guys, is this good or is this bad for us? Yes, this is good for us, right? This is a measure of accuracy. What about this? Is false positive good or bad? False positive, is it good or is it bad? It is bad, right? Because this is false positive. It is a mismatch. So now what we have to do is, on this axis, we will want to be as high as possible on this axis, right? On the y axis, because this is good for us, right? This is good for us and this is bad for us. So we will want to be as high as possible on this axis and as low as possible on this axis, right, guys? So let's say if I am here, this is, let's say, 100% and it is 100% here. So if I select this as the threshold, if I select zero point 0.9 as, if I select 1 as the threshold, let's say I select 1 as the threshold. Okay, 1 is this point, origin. So what will happen if my threshold is 1? How many true positive will I predict? If my threshold is 1, what will happen? How many true positive will I predict? So how do I predict my positive? I say that if it is greater than threshold, it is positive, right? It is positive. And if my threshold itself is 1, obviously I will not have anything which is above, any probability which is above 1. So it will be 0. From this figure also you can say, if my threshold is 1, my true positive will be 0, right? Because I am not going anywhere on this axis. But what will be my error? What will be my error? If my threshold is 1, that means I am predicting all 0. I am not predicting any 1, I am predicting all 0. So what will be my false positive rate? What will be my false positive rate then if I am predicting all 0? So if I'm predicting all 0, that means this is 0, this is 0. So false positive rate will always be 0, right? So my error is 0, but the model is useless because I'm not predicting anything. Okay. My model is useless because I'm not predicting anything. I'm just saying that nobody has cancer. So my false positive is 0. I did not say anybody who does not have cancer as having cancer. There my error is 0. But it is useless. I did not identify any model. So you have to go up. And as you go up, your error will increase. As you go up, your error will also increase. So what you try to do, and on a similar line, if you take threshold as 0, if you take threshold as 0, how many positives do you predict? How many positives do you predict if you take threshold as 0? All, right? All positives. You predict that everything is positive. So the baseline method predicting 1 always. So that means your false positive will be, what will be your false positive? That will also be 100%, right? Because even those who did not have cancer, you predicted they have cancer. So if there were, so from the previous example, out of 10, if 8 have cancer and 2 does not have cancer, and if you say that all 10 have cancer, so obviously your error, your false positive is also 2, right? All of them. Because these 2 did not have cancer, but you predicted they have cancer. Right, guys? So this is also meaningless. Your accuracy is 100% here, but your error is also 100%. Okay. Your accuracy is 100%. Your true positive rate is 100%, but false positive rate is also 100%. So this is also useless and this is also useless. So you have to be somewhere in the middle. So where do you want to be? We want to be as high as possible on the y axis, but as low as possible on the x axis. So maybe I can select a point here. So let's say I select a point here. I select a point here and I select a point here. So if I select this point, so let's say this is point 1, this is point 2, this is point 3. So if I select point 1, my accuracy is maybe around 50% and my error is around very small, so maybe 10%. If I select the second point, my accuracy is around 90%, my error is around 25%. If I select the third point, my accuracy is around 95%, but my error is around 40%. So this is how it looks like. So which one will you select then in this case? Yeah, so it you will usually go with 2, but again it's a business decision. What do you want? Are you okay with some error So again, for example, the cancer thing, right? The identifying the cancer patient. If your business is that complex that not identifying a correct patient will result in death of the patient, then you will select this. Then you will select this. Okay? Because you have to identify the ones, no matter what is your error. You don't care about this error. You have to identify all your ones. Then you will select this. But otherwise, you will select this. Okay, if you are okay with some ones getting missed, you will select this. Okay guys, do you understand? Let's say if it is a minor disease, let's say if it is a minor disease which involves a lot of cost, if it is caught basically, then you will go by this, because it is a minor disease, not a big issue. Even if you are not able to catch, it's okay. But if it is a disease like cancer, where there is it may result in the death of the patient, then you will go by this, because you want to be 95% sure. It's okay if you are saying that somebody doesn't have cancer also has cancer. It's okay if that is there, but you have to be maximum sure. No, it need not be. It need not be 100% serum, because you are measuring two different things. This is true positive rate. This is false positive rate. It need not be 100%. Okay, it need not be 100%. Okay. So this curve helps you determine what threshold you should select. So you can plot this curve basically. So we will see in the next class, we can plot this curve. And from this curve, you try to select points somewhere here, which is very high on the y-axis, but very low on the x-axis. Okay. And if your model is very good, if you have a very good model, your plot will look something like this. If you have a good model, your plot will look like this. But if you have a bad model, your plot will look like this. Okay. So this is a bad model and this is a good model. You see that, right? Why this is a good model and this is bad? Because here you can easily select this point, which will have very low error. It has only this much error and very high accuracy. But in this model, how will you select? No matter what point you select, your error is also high and your accuracy is also low, right? This is a bad model. Understand guys why this is a good model and this is a bad model? Because this allows you to easily select a point which will be high on y-axis and low on x-axis. But this model, this plot does not allow you to select such a point. It is very difficult to select such a point. So your model should be like this. It should go as high as possible and then come towards the right. Okay. So this is the best model. This is okay and this is bad model. And if you draw your baseline model here, it looks something like this. Your baseline model will be a straight line at 45 degree. Okay, this is your baseline model. Do you get it guys? And one thing I missed, another way to evaluate the accuracy of a logistic regression or any classification model is to find the area under this curve. Okay, it is known as AUC. Higher the area, better is the model, which you might have understood, right? This model has higher area than this. So if the area is close to 1, it is the best model, 100% accuracy. If it is close to 0, it is not a good model. Area also goes between 0 and 1. Okay, area is like the probability here. So if you are close to 1, that means it is a good model. If you are close to 0, that means it is a bad model. AUC stands for area under curve. You can calculate this in Python. Okay, this is area under curve. Yes guys, so I'm almost done with all the topics for today. We covered quite a lot. So tell me if you have any doubts, or I'll start with the revision now. Yeah, Aurangzeb. So I'll figure out a way so that I can hand over the recordings to you guys. Okay. So actually the problem is I don't have video files for this. Okay. So this software, the tool that I'm using to teach, this tool automatically creates the recordings, and it basically saves on the whatever website you guys log in, right, to see the to watch the videos. So what I will do, actually there is another subscription. I'll have to basically pay something, and if I pay, I will be able to download the videos. So let me see if I can get that subscription. I'll have to pay some additional 10-20,000 for that. But anyways, I'm planning to take that subscription because it will be helpful for me as well. Okay. And anyways, I'm going to continue this online thing even after your batch. So January, I'm planning to start a new batch that will be in R. Okay. So even there I will be needing it. So I am planning to take that subscription anyways. So January I should be able to share the files with you. Okay. Or what I will do, once I have the files, I can upload them on YouTube also. So I can upload them on YouTube in private mode and send the link to you guys so that you can refer it. But it will not be publicly available to anybody. And I expect you guys will not share it so that that doesn't kill my business basically. Okay. So students, instead of coming to me, they will just see my videos. So that should not happen, right? And I'm okay if students are able to do that. I'm okay with that. So I teach because I like teaching, not because I want money. Obviously, if you get money, you are happy, but that is not the primary goal. Okay, guys. So let us do a quick revision then. Okay. So don't worry. I will figure out a way to share the videos with you. I understand that the videos will be required. Okay. So yeah, YouTube probably will work, because some of you are from Chennai and other places. So I don't think I'll be able to share so much videos because the video size is huge. So one video is around 600, 700 MB. So overall, I think by the end of the course, we will have some 10 GBs of video. So I don't think I'll be able to share those on Google Drive. So maybe I'll upload them on YouTube. Okay. So let's do a revision then. Okay. So what did we see today, guys? Can you help me recollect? It's a lot of things. So what did we start with? What was the first thing that we saw? Yes, guys. Yeah, so we saw the hands-on of logistic regression, right? So let's talk about the hands-on part a little bit. So what did we see? We saw that we use the codes are pretty simple to linear regression, right? The codes are pretty simple. We first import the linear regression function, then we divide the data, we split the data into two parts, train and test, and then we decide what is our X train, we decide what is our X test, then we decide what is our Y train, and what is our Y test. So we basically divide the data into four parts: the dependent variable, the independent variable, and training and test. Train and test. So these four parts we divide our data. After this is done, we call the function that we have imported. right? We call that function and create an object. We create an object and then we pass the training data. We pass the independent variable of training and we pass the dependent variable of training to build our model in this object, right? Once we have built our model, we predict on the test data. So while predicting, we just pass the training, we just pass the independent variable of test data. We don't need the dependent variable to predict. That is already there, but we don't need it. We just need the independent variable to predict. So in logistic regression, if you use this command, you get zeros and ones directly. Okay, you will directly get zeros and ones, assuming a threshold of 0.5. So this function assumes a threshold of 0.5 and it will convert your probability to zeros and ones directly. But if you want your own threshold, you can use predict dot prob a. Okay, the same input. Dot prob a is what you will use if you want your own probability. Then you will get probability of y is equal to 0 and you will get probability of y is equal to 1. For all the rows in test data, you will get this. Okay, you will get this for all the rows in the test data. But what you want is this. This is what you want, right? Because if you remember in logistic regression, this is what you have on your left hand side. This is what you have on your left hand side. So you have to select this from this data. So this comes in the form of an array. You have to select this from the array. So we saw, let's say if this is x, we saw how do we select that from the array. We just write x and we give this column number. This column number is 0, this column number is 1. So we give 1 here. And we want all the rows, so we leave blank here. We just give the colon and we leave it blank here. So that means all the rows but second column. Okay. Why 1? Because the index starts from 0. This is 0, this is 1. So we give this, we get this particular thing we get. Next we compare it with a threshold. Whatever threshold you want to give, you compare it with that. If it is greater than that threshold, you say it's 1. If it is not greater than that threshold, you say it's 0. Okay, so you have your prediction values. Either by this or either by this, you have converted your predictions to zeros and ones. So now you can build your confusion matrix. You can build your confusion matrix now. You will have your actuals here. You will have your predicted here. Okay, and then you compute these parameters. You already saw what is your accuracy. It is true positive plus true negative divided by total. Okay, and you know your error also. It is 1 minus your accuracy. This is your error. Okay, we also saw certain other parameters. Let's discuss that now itself. So we saw sensitivity, which is also true positive rate. So true positive rate is nothing but true positive divided by this row total. Okay, so true positive divided by true positive plus false negative. Okay, this measures how many ones are you identifying out of the total actual ones. Okay, out of total actual ones. So ones out of total actual ones. Okay, then we saw specificity, which is true negative rate. Okay, specificity is true negative rate. What did we see there? The formula for that was true negative divided by true negative plus false positive. Okay, this was the formula. This is zeros out of total actual zeros. Okay, how many zeros did you identify out of total actual zeros? This is what it measures. Then you saw what is precision. Precision is true positive divided by column total now. So false positive plus true positive. Okay, what does this measure? This is very similar to this. Okay, this is very similar to this. So ones out of total, now predicted ones. Okay, instead of actual ones, I'm writing predicted ones now. Otherwise it's the same. Okay, they have the same numerator. So these are your three terms which we use to find the accuracy of a model. Okay, we will find this using accuracy. So we will see this. We will see this in the next class. Okay. Then what else did we see? Okay, let's talk about thresholds here itself. So we also saw that, okay, another parameter. So these are all parameters which is used to evaluate a model, right? Sensitivity, specificity, precision. We also have another parameter which is AUC parameter, okay? Area under curve. This is another parameter. This also takes values between 0 and 1. It is a percentage basically. So 100% means you are 100% correct. You have captured all the ones correctly. You have captured all the zeros correctly. That is your 100%. Okay. Now where does this come from? It is area under which curve? It is area under the ROC curve. Okay. So what is ROC curve? ROC curve is what helps you decide the best value of threshold to take. Okay. What does it have on the y-axis? It has sensitivity on the y-axis. Okay, it has sensitivity on the y-axis, which is nothing but true positive rate, and it has 1 minus specificity on the x-axis. 1 minus specificity is nothing but false positive rate. Okay, so this is like a error to us, and this is like a accuracy to us. Okay, so we want to be high on this axis, but at the same time low on this axis, and the curve generally looks like this. Okay, so you might select this point or this point or this point. The threshold starts from 1 and goes to 0. It is opposite, okay? Always remember. Not from 0 to 1, but 1 to 0. So you select the appropriate threshold based on your business requirement. Okay. So these are some potential values of threshold that you can select. Okay. You might select this or this or this. If you want low error, but you are okay with low accuracy also, you select this. If you want high accuracy, but you are okay with somewhat high error also, you select this. And if you want very high accuracy and you're not at all concerned about your error, then you select this. So based on your business requirement, you select these thresholds. Okay. So this is all about your AUC, ROC curve. And AUC is nothing but the area under this curve. AUC measures the area under this particular curve only. So this area is your AUC. Okay. What else, guys? What else did we see? Yes, guys, what else did we see? We saw how do we find important variables, right? Yeah. So we saw how do we find important variables. The first method, if it is linear regression, we just find the correlation. Okay, if your variable is continuous, if both independent and dependent are continuous, you find the correlation. If they are not continuous, in case of logistic, where you cannot find the correlation, you try to draw plots. So what kind of plots do you draw? If both are categorical, if both your dependent and independent variable, dependent and independent variable, if both are categorical, you draw count plots. Okay, you will draw count plots. So we will see this. So the case study that I have shared, you will see this there. Okay, we will draw count plots. If in the count plots you see a very distinct variation between the two categories, let's say one is green and one is red. If you see a clear distinction between the two categories, that means your variable is important. Okay, so in this case I see a clear differentiation. Let's say this is 0, this is 1. Okay, so I can say that if I have green, then probably he belongs to 1, right guys? If it is green, if your the independent variable is green, then probably he is 1, right? Because most of the greens fall in this one. So this information you get from the count plot. Similarly, if if your dependent variable is categorical but your independent variable is continuous, then you can draw a histogram. Okay, let's say you draw a histogram, it looks like this. Now here you might have distributions like this. Okay, with half of it being green and the other half being red. So this is not of much use, because at any point you cannot say with confidence that you are green or you are red, because you have chance of both. So any segment you select, you have both green and red, so you cannot say. But if your histogram is like this, where you have total green on one side, and let's say this is y, you can say if your variable is greater than y, it is green. You can clearly distinguish that this side you have only green and below this you have only red. So you can clearly say that with confidence. Okay, so this is useful to you. This is not much useful. Okay, so this through this method, but this is a very tedious process. You have to do this one by one, right? You have to do this one by one. You cannot plot multiple variables. This is a two-dimensional axis. So one variable at a time you will have to plot. So imagine if you have 20 variables. If you have 20 independent variables, imagine how many times, 20 times you'll have to do this. Okay, but that is how it is. Or if you are not able to do this, you can rely on p-values. You'll have to get the p-values. We already saw the codes for this. I'll send the codes very soon, maybe by not by today, by tomorrow I'll send you the codes. Okay, I'll add some more comments to the code so that it is easy for you to understand, and by tomorrow evening I'll share the codes as well as the video. So video also I'll be sharing tomorrow, today's video. Okay, it takes some 7. So today we had a 4 hours of class, so it might take almost 6 hours to prepare. So I won't start the preparation today, I'll start it tomorrow only. Tomorrow in the office I'll start. I want to give some rest to my laptop also. Okay, so one by one, p-values, you will look at the p-values, and looking at the p-values you will identify variables which have less than 5% p-values. You will say that those variables are important, and only those variables you will keep in your model. Okay, you will keep only those variables in your model to select the final list of important variables. And why are we doing all of this? Why can't we include all the variables to get rid of this headache of finding important variables? Because if you include all your variables, you will be a overfit model. Your model will be overfit. It will not do good on the test data set, right guys? So overfitting we saw tomorrow, so I don't think I have to revise that today. We already revised that during the beginning of the class. Anything else that we covered today, guys? Yeah. So the baseline model always predicts the baseline model always predicts the mode. So if you have 60 ones and if you have 40 zeros, the baseline model will always predict 1. Okay, it will always predict 1 for everybody, and it will have an accuracy of 60%, right? Because 60% of the times it will correctly identify, right guys? You're getting right? If 60 are 1 and 40 are 0, and you say 1 all the time, still your accuracy will be 60, right? Okay, so this brings us to a very interesting problem. So the interesting problem is imbalanced classes. So though this is out of scope of this course, I won't be covering this because this is very difficult. Even I don't understand this very clearly. So imbalanced classes is, for example, very rare disease. Okay, very rare disease which happens to 1 in 1 lakh. So there what will you have? You will have 999 people zeros, and only one person is having a 1. So only this person has this disease. So this disease is 1 in 1000, which is not rare, by the way. Some diseases are 1 in 1000, 1 in 10,000, 1 in 1 lakh. You have those diseases. Okay, some genetic disorder and all. Okay, so in this case what happens? If you go by a baseline model, in this case, what will be your accuracy? In this case, if you go by a baseline model, what will be your accuracy? So if you go by a baseline model in this case, you will predict always zeros. And what will be your accuracy? No, in this case, you will always predict 0. because zeros are more, right? You will not predict 1, you will predict 0 always, because baseline model predicts the mode. Okay. No guys, it will be 99.99%, right? 99.9%. Why 0.01? It is 99.9%, right? Because you are predicting always 0. So you are catching all these guys correctly, but this guy you are not able to catch. So it will be 99.9%. Understand? The baseline predicts whichever is more in the data, not always 1. In this case, since 1 was 60 and 0 was 40, it predicted 1. But here 0 is more. So it will predict 0 all the time, not 1. Whichever is more, it will predict. Mode, it will predict the mode. You know what is mode, right? The value which occurs more in the data. So its accuracy will be 99.9%. But is this model useful to us? No, right? We did not catch that single person also. This is a total waste model, but still has a very high accuracy. So you should not always rely on this accuracy, okay? This accuracy might not be the right way to see a model. It might be totally useless. So in this case, for example, though we had 99% accuracy, this model is useless because we did not catch even a single one. Okay. So in this case, we should measure sensitivity or the true positive rate. So this will be true positive divided by something, right? So what is true positive? Your true positive will be 0. So sensitivity will be 0 in this case because you did not catch even a single one, because true positive was 0. So it is 0. So it is a waste model. So you should not rely on the accuracy. Sometimes you will have to measure the sensitivity. That is why we have so many terms, depending upon what is important for you. If 1 is important to you, you measure sensitivity. If 0 is important, you measure specificity and so on. Okay, clear guys? Okay, what else? Anything else did we cover? Any doubts? So don't worry guys, a lot of theory has been covered, but these theories, for example, all these things will remain the same in the other algorithms also. So in the other algorithms, you will not have all these things coming again, because finding important variables, this has nothing to do with modeling. Okay, so this will remain the same. Similarly, all these things that we discussed, sensitivity, specificity, all these things will remain same in other models also. The only thing that will change is how do you get the probability. So here we are getting the probability from the logistic response function. There we will get the probability from some other function, but these things will remain the same. So you won't have a lot of things to learn. Okay, because these things remains the same. The only thing which changes is getting the probability out. After you have the probability out, it is the same method. Similarly, if it is a regression problem, only getting the prediction out is will change. After the prediction out, you will do the same things. You will find the mean absolute percentage error, the sum of squared error. So those things will not change, because those things are how do you evaluate a model. So how do you evaluate a model will not change. Only the model will change. Okay, for example, ordinary least square, instead of ordinary least square, you might have something else. Instead of maximum likelihood estimate, you will have something else. But the evaluation techniques will remain the same for all algorithms. So these things will not change. Okay. So okay guys, let's call it a day then. We learned a lot in this week. Actually, I was planning to complete logistic in this week. We are running behind, we spent a lot of time doing Python. We spent almost a month doing Python. Whereas the a lot what I had planned was just 2 or 3 classes in Python. But we spent almost 7 or 8 classes in Python. So we are running behind. Okay, so we have to pick speed actually. So what I was planning is I wanted to finish up logistic regression in this week. so that we can start with something new in the next week. So what do you think, guys? So let me see. Maybe if I am free, or if you guys are free, we can have a class on Wednesday, just 1 hour class. I will just walk you through the codes. Or if that is not possible, if I am busy or if you guys are not busy, what I will do is I will record it and I will post. I'll give it to you. Okay, I will record it at my own time, and then I'll send you the links and you can go through it. Okay, and it won't be a lot. It will be just 1 hour or 2 hour max. Okay, so we can do that. And I will send you some homework for logistic also. I will send you the codes that I have written today, and a case study. Of course, I will send the case study will have all the codes, and I will send you one homework as well. So make sure you guys are doing the homeworks which I'm sending. Okay, because I'm taking a lot of time to prepare the homework. I'm spending almost 1 hour, 2 hour to prepare the homework. If you guys don't do it, all that effort will go in vain. Okay, so please do the homework, guys. Okay, I won't be checking your homework, but that is for your own benefit. Nobody is going to check it. Okay, you can compare the answers within yourself. So I think so far I have sent 3 4 homeworks, but I barely saw anybody discussing about the homework. Any place where somebody was stuck, I did not see. So try to do that.